Hello everyone. I welcome you to this third session of surface areas and volume. Let's start. Exams Vidhai is a non-profit initiative by the students of IIITDM Kancheepuram to help students get free coaching and resources in preparation for different competitive exams. So, as we have seen in the previous session, the contents of this chapter or these videos, we have gone through 2D, what are 2D shapes and 3D shapes, surface areas of different shapes, volumes of different shapes, and now today we'll be learning how volume remains same or what changes and what does not change when a shape is converted from one form to another. And in the coming up sessions, we'll be seeing frustum of a cone, which will be the last session. So let's start. So, how does conversion takes place of an object in one shape to another shape, and what remains same and what changes? So let's see. For example, let us take an example of a candle, which is in the shape of a cylinder. Candle melts upon lighting it up, and wax is generated, molten wax is generated as a result of the heat. And sooner when it gets melt, gets accumulated over a place, and upon cooling down become harder like a solid, and acquires a shape in which it is placed. So similarly, if if a candle is in the shape of cylinder and later while melting it's placed in a cube shaped object, then the wax acquires the shape of the cube upon cooling. Or if an object of in the shape of rabbit is present, then the candle will obtain the shape of the rabbit. So here, what we observe is the volume of the object is remaining same. The volume from which it melts acquires in the shape of another object. So the volume is remaining same, but you see the area of the object are changing. It's changing from cylinder to a cube. Over here, suppose water is in a cylinder and it's transported or put in a tube shaped object, then the water acquires the shape of the tube, which is combination of cylinder and a small hemisphere. So we observe that whenever an object is converted from one form to another, or when liquid is transferred from one object to another object of different shape or size, volume remains same. But note that the size, not the size, the surface area changes of the object because object is changing. So these are the main conclusions which you should take from this concept of conversion of one shape to another or one form to another. So let us understand more about this by solving an example. So here a cone of height 24 centimeter and radius of base 6 centimeter is made up of modeling clay. I think every one of you knows what a clay is. You can make different shape upon using it, which you see many children playing, and we too in our childhood have played with a lot. So a child is present, so he reshapes it in the form of a sphere. So we have to find the radius of sphere. Okay. So here there's a cone which is converted to the shape of sphere. Since we are given the radius of base of cone and the height of cone, we can find the volume of cone. You know that when one shape is converted to another form and adjusted to a different shape, the volume remains same, but the surface area changes. So we can find the volume of cone. We know that the formula for volume of cone is 1 by 3 pi r square h, where r is the radius of base and h is the height of cone. And we also know that if r is the radius of the sphere, then the volume becomes 4 by 3 pi r cube. Since the clay used is same, so the volume remains same. So volume of the taken from the cone, the same volume is used in the sphere. So volume is remaining same. So volume can be equated. So 1 by 3 pi r square h equals to 4 by 3 pi r cube. So here r we know it as 6 and h we know it as 24. Pi can be cancelled and you get r cube as 3 into 3 into 24, which we further get as r taking the cube root of 3 into 2 and we get as 6 centimeters. So we get the final answer, that is radius of the sphere as 6 centimeter. So the conclusions you should take from this problem is when an object is converted from one form to another and acquires the shape of another object, here volume remains same. Here clay is the volume which is acquiring initially the shape of a cone and then transforming itself into the shape of sphere. Hence volume remains same. So now let's move on to one more problem in order to understand more about it. So let's see. Okay. A copper rod of diameter 1 centimeter and length 8 centimeter is given, which is this, is drawn into a sphere of length 18 meter of uniform thickness. So we have to find the thickness of the wire. So here a copper rod of diameter 1 centimeter and length 8 centimeter is given. This copper rod has to be drawn into a wire of length 18 meter, which is of uniform thickness. So we have to find the thickness of the wire, that is nothing but the diameter of the cross section of the wire. So, what can we do here is, first of all, we can see that the copper rod needs to be stretched in order to acquire the shape of this wire. In order to stretch it, we know that radius is inversely proportional to the height. So, when radius increases, the height decreases, and when the height increases, the radius decreases. So, we can say it in a better way as length rather than height. So when length increases, the radius decreases. So here volume remains same because this copper rod is being drawn into this wire of uniform thickness. So let's find. So the volume of the rod is in the shape of cylinder. So we can find the volume of rod by pi r square h, where r is the radius and h is the height. Pi into radius square into height, we'll get it as 2 pi centimeter cube. So the length of the wire is 18 meter. Taking it in all as a single unit in order to avoid confusion and for easier calculations, 800 centimeter. So, assuming the radius of the cross section of wire as r, then we get the volume as, we know that this is a cylinder, so pi r square h, that is nothing but pi into r square into 1800. Therefore, we know that volume of rod is same as the volume of wire, that is 2 pi equal to pi r square into 1800. So we cancel pi and simplifying it further, we get r as 1 by 30 centimeter. We know that the diameter is twice of the radii. So we get the thickness of the wire, that is nothing but the diameter of the wire as 1 by 15 centimeter, which is approximately 0.67 mm. So the conclusions we need to take from the question is that overall, when is same as the previous question, that whenever an object is being converted from one form to another of another shape or acquiring the shape of another object, then volume remains same. So hence the copper rod is stretched in order to attain to be drawn into the wire. So the final volume remains the same. Thus bringing us to the end of the session. So thank you for attending, and please leave the doubts in the comments below. Hope you understood about the topics discussed in this session. Thank you.